Hey everyone, before we get into chapter 2, I want to do a little intro to chapter 2. I'm calling this AKA the things you need to know how to do before we start the next chapter. So chapter 2 is going to be all about fractions, decimals, and percents. So in order to transfer between fractions and decimals and percents, there are a few skills that you need to know, or a few skills you need to practice and refresh your brains on before we actually get into chapter 2, because if you know how to do these skills, you're going to do a lot better in chapter 2. So we're going to start do a little pre-chapter is what we're going to call this. So the first thing that you're going to need to refresh your brain on are, what are they? It might have been a while since you've done some of these things. Fractions should be the one that's most common, but what are fractions? What are mixed numbers? What's a decimal? What's a percent? So we're going to start off by talking about the difference between all those things. The second thing you'll need to know is place value. If I gave you a number with a decimal point, you should be able to tell me the place value of all the numbers in it. So we're going to practice that here in a second. What's the 10th spot? What's the 100th spot? What's the 1,000th spot? Things like that. And then you also need to refresh your brains on how to do long division. I know this is a struggle for some of you. We will practice it. And if you need individual help on long division, see me. But we'll practice a little bit, because if you know how to do long division, I promise this chapter is going to be so much easier than it would be if you don't know how to do long division. So we're going to practice how you divide two numbers. Okay, so what are they? Fractions, I think you're all familiar with, right? Fractions are part of a whole. So if I was looking at this right here, this is a one whole pizza or one whole pie or whatever else is circular that you can think of. If I had half of it, I'm not going to have the whole thing, right? I have half of it. That's a fraction of the pizza, or a fourth or 3/4, whatever the fraction is, it's part of a whole. Right here, if I'm pulling off this piece of the candy bar, that's part of the candy bar I'm pulling off. So that's a fourth of the candy bar, or 1/8 of the pizza. Over here, I can see that different fractions are sometimes equal to each other. 1/2 is going to be the same as 2/4 together, or 4/8 together. So however you break it up, fractions are going to be taking parts of a whole and putting a numerator and a denominator. Numerator is always on top, denominator is always on the bottom. Mixed numbers. Mixed numbers use fractions and whole numbers, and they mix them together. That's why they call them mixed numbers. So a mixed number is a mix of a whole number and a fraction. So in this one where you see the picture, I see that I have one whole box filled in, and I have 3 out of 4 pieces of the next whole box filled in. So I have a full box and I have part of a full box. So I have one, and 3/4 of the other box, 3/4. So I have 1 and 3/4 shaded. That's a mixed number. I could call another mixed number 4.5. So I would have 4 holes shaded, and then I would have half of another one shaded. Or if I took this picture and added 4 more boxes, then I would have 5 holes shaded, and I would have 3/4 of the last one shaded. So that would be 5 and 3/4. So that's a mixed number. Decimals, all right? Decimals use decimal points. Decimals are all about place value. So if I was looking at this number right here, 45.6, I know that 6 is in the 10th spot, 5 is in the 1 spot, and 4 is in the 10 spot. And that can help you figure out what part you are working with. Here are some examples of decimals: 8.2, 0.1. So if a 0 is in front, that means I don't have any holes, just like when we talked about mixed numbers. But if a 2 is in front, that means I do have 2 holes, and then I have 65 hundredths of another hole if I was looking at this one. In this example, I have 0 holes and 75 hundredths of another hole. So as you can see here, if I have 75 hundredths of a pizza shaded in, that means I have 3 out of 4 pieces shaded in, because that's equal to 75 hundredths. We're going to get into that a little bit more into chapter 2. And then percents, you a lot of times might see these at grocery stores or on sales and things like that, clearance. So percents are going to be part of a whole as well. All right, you can go over 100%, which we'll get into, but a lot of times you're going to see percents under 100. So if I have 25% of a pizza, that is not 100% of the pizza. That's only 25% of it, which means it's going to be a fourth of the pizza. So some other percents you might see 40%, 25%. You might see something called 25% off. That means you get 25% off of the price, which means it's going to be a cheaper price. So that's percents. All right, so hopefully we know the difference between those words. Now, when we get into place value, this is something that's crucial for math the rest of your life. You need to know place value. So this is a little chart with place value, and we're going to practice a few here in a second. But we always find the decimal point, and that tells us what all the place values are going to be. If I'm working to the left of the decimal point, I'm working with whole numbers. If I'm working to the right of the decimal point, I'm working with rational numbers, or numbers that are going to be less than 1. All right, they're not going to be a full because wholes are over here. So these are going to be fractions, if you will, but we're going to use decimal format. So I have tenths, hundredths, thousandths, always ending in that THS. If I kept going, it'd be 10 thousandths, and you can keep going. Okay, so let's look at a place value chart. If I was looking at a place value chart and I wanted to plot this number down, 2,456 and, because that's our decimal point, 738 thousandths, I would put those numbers in right here. 2 in the thousand spot, 4 in the hundred spot, 5 in the 10 spot, 6 in the 1 spot, decimal point, 7 in the 10 spot, 3 in the hundredth spot, and 8 in the thousandth spot. So then I could look at this number and I should be able to figure out place value for all of these. So let's look at the number 5. 5 is in the 10 spot. I know it's to the left of the decimal, so I'm looking at whole numbers. Well, if I have 5 tens, that's basically like saying 10 plus 10 plus 10 plus 10 plus 10, 5 times, right? So that means I have 50. So this 5 in the 10 spot is really worth 50. If I was looking at that 4 in the 100 spot, that's really worth 400, right? So then if I'm looking to the right of the decimal point, though, I'm looking at that 7. That 7's to the right, so I know it's not bigger than 1. All right, it's going to be less than 1. That's in the tenths spot. So when you're thinking about 7 tenths, I can really think about that as a fraction, right? So 7 tenths is really the same thing as saying 7 over 10, right? 7 tenths. That makes sense. So then if I was looking at the place value chart again with the same number, but let's say I circled the 73, all right? All right, I see 73. That's both to the right. I'm always going to look at the number that's furthest to the right to figure out what my denominator is, okay? So I'm not going to put this over 10 because there's one further to the right. So this 3 is the furthest number to the right. So we're going to use 100 as our denominator here. So really, 0.73 is really like saying 73 over 100 or 73 hundredths, okay? If I was looking at all three of these together, 7, 3, 8. That's all to the right of the decimal point. My furthest one over to the right is 8. So we're going to use thousands as our denominator, so 1,000. So this is really like saying 738 over 1,000. So that's kind of how we work with place value here. So now I want you to try. So if I were to give you a number like 5,954 and 286 thousandths, I want you to tell me what the different parts would be. So if I circled 2.8 in this problem, so 0.28. How would you put that as a fraction? 0.28 as a fraction. Okay, if you did this correctly, you should have seen that 8 is the furthest one to the right, so we're in the hundredth spot, so our denominator should be 100, and then 2 is in the 10th spot, so we're going to put that as 28 over 100. All right. Now, let's get into long division. This is going to be the tricky one, but I think you guys can do it. And I am going to go to my smartboard at some point to help you out as well. So to work out a problem. So hopefully you can hear me. So I will tell you right now, if you know how to do long division, you're converting fractions to decimals is going to be so much easier. Okay. So if you know how to do long division, it's going to save your life and help you out so much in chapter 2. So if you don't know how to do long division, this is something that you could practice during Harbor, something you can practice on your own at home. You can Google Meet with me. We can work through them together. But long division is going to be a skill you're going to use for the rest of your life. So when we're doing long division, we always want to go through these steps: divide, multiply, subtract, and bring down. So if I was dividing 894 divided by 3, I would put 894 inside the house, put 3 on the outside of the house trying to get in. So we want to figure out how many times can 3 get into 894's house. So we start by looking at the first number. So how many times can 3 go into 8? When I think about 3 into 8, well, it can go in twice, right? 3 times 2 is going to give me 6. So I'm going to put 6 right here. And I cannot fit 3 in another time. Otherwise, it would go over that 8, right? So I do 8 minus 6, which is our subtract part. We're going to get 2. Then it says to bring down. Okay, so I see that I have a 9 right here I can bring down. So now I'm looking at 3 into 29. So how many times can 3 go into 29? Well, I know that 3 times 9 is 27, so that's pretty close. So 3 times 9 is 27, so 29 minus 27 is 2. And then we got to bring down again. So I bring down that final 4, and we're hoping that this works out perfectly. So 3 times what gives me 24? Well, I know that 3 times 8 gives me 24. 3 times 8 gives me 24. And that's perfect because it leaves us with 0, so that means we are done. And 3 goes into 894 298 times. So 894 divided by 3 is 298. So let's do a couple simple ones together. So if I want to do 64 divided by 4, All right, I'm going to work out a long division problem with you on the smartboard, and I want you to follow along. All right, so if I was doing 64 divided by 4, turn on my microphone here. Good. All right, I want to put 64 as my house. Hopefully my smartboard starts connecting here. So if I have 64 inside the house, I'm going to put 4 on the outside of the house. I want to figure out how many times can 4 go into 6. So 4 goes into 6 one time. So I'm going to bring down that 4. 4 times 1 is 4. Subtract them and put a 2 here. So 6 minus 4 is 2. Remember, I have to bring down that 4 now. How many times can 4 go into 24? I know that 4 can go into 24 6 times. So I'm going to put my 6 here. 4 times 6 is 24. So I'm going to put 24, subtract it, and I'm going to be left with 0. So I know that 64 divided by 4 is 16. So that's a quick example of how to do that with a basic long division problem. Now, let's do another one on your own. 76 divided by 4. I want you to try this one on your own. Here's how you should set it up. 76 inside the house, 4 on the outside. Okay, if you did this correctly, you should know that 4 goes into 7 only one time. Because if I did 4 into 7 twice, that would be 8, which would be too many, right? So 4 goes into 7 one time. So I'm going to do 4 times 1, which is going to give me 4, and subtract. So 7 minus 4 is 3. I know I have to bring down my 6. Boom. How many times can 4 get into 36? Well, 4 times 9 gives me 36. So I'm going to put 9 up here. So 4 times 9 is 36. 36 minus 36 is 0. So boom, there's my answer. So 19 is the answer for 76 divided by 4. All right. Now, when we're working with fractions, we can always turn them into decimals, which we're going to get into in chapter 2, by doing long division. So in this situation, I have 3 divided by 8. And you might be thinking, oh, that's kind of weird because the number on top is smaller than the number on the bottom. But we can still do it. So if I set this up as a division problem, I'm still going to put the 3 on the inside of the house, and I'm going to put 8 on the inside of the house. So I'm looking at this problem, and I'm like, oh, man, how do I do this? Because I can't put 8 into 3. Well, the cool thing is, 3 is the same as saying 3.000, and I can keep going, right? So I can add those extra filler zeros to figure out my problem. So I know that 8 goes into 3 0 times, so I can put a 0 up there if I want to. But then I can move on with this problem, but I'm going to rise this decimal point up as I keep going, all right? So I'm going to put that decimal point there, I'm going to leave it. So now I need to figure out how many times does 8 go into 30? Well, 8 goes into 30, let me think about that. I think that goes into 33 times, right? So I'm going to put 24, because 8 times 3 is 24. So 30 minus 24 is going to leave me with 6. I'm going to bring down my 0, all right? So how many times does 8 go into 60? So I know that 8 times 7 is going to give me 56, which is going to be pretty close to that, right? So that's going to go in 7 times. So 8 times 7 is 56, and subtract, and I'm going to get 4. All right, I have another 0 I can bring down. Remember, I can keep these zeros going if I want to. But let's see if this works out. So I have 8 going into 40. I know that 8 times 5 is 40 perfectly. So I can put my 5 here. This would be 40 down here. That's going to equal 0. And boom, my decimal point is 0.375, or a better way to say that is 0 and 375 thousandths. Okay? So that's how you would work out that long division problem. We're going to practice that in this chapter. So I want you to try one on your own. I'm going to set it up for you, but I think you can do the math here. So on the inside of my house, it says 2 divided by 5. 2 is the inside of my house. 5 is on the outside. Add your decimal point. Pull it up there. And then add your filler zeros. Okay, now figure it out. All right, if you did this correctly, can 5 go into 2? No, it cannot. But can 5 go into 20? Yes. 5 can go into 20 how many times? 4. So 5 times 4 is 20. 20 minus 20 is 0. So the answer to this one would be 0.4.